Okay, so we're going to start with this modeling quadratics little mini lesson here, and we're going to do the International Silver String Submarine Band holds a bake sale each year to fund their trip to the National Sasquatch Convention. It's been determined that the cost in dollars of baking X cookies is C of X equals 0.1X plus 25, and that the demand function for their cookies is P equals 10 minus 0.1X, 0.01X. For X is between 0 and 1,000. So they've established a domain that basically represents where X is the number of cookies that they're going to produce, and C of X is the cost, and P represents the demand function, which means, sort of what price is the market willing to pay based on what they have. So, or the number of cookies they produce. So if we want to know how many cookies they should bake to maximize their profit, okay? So the first thing we need to do is, think like a business person. What represents profit, okay? Profit is basically our revenue minus our cost. Okay, so we've got the cost function up here, so that's going to sort of be subtracted off. We'll put that in our sort of hip pocket and just leave that there. But now we need to figure out, how do we calculate revenue? Well, we know the demand function, which is the price of our cookies based on how many we produce, is 10 minus 0.1x. But revenue is really price times the number of cookies, in this case, we sell. So we are going to take our revenue, our P function here, and we're going to multiply that by X. So our revenue is going to be, revenue is equal to 10 minus 0.01X times X. So we're going to subtract from that revenue minus cost, so we're going to have our profit is equal to 10 minus 0.01x times x minus 0.1x, and I'm going to put this in parentheses, 0.1x plus 25. In simplifying this, I get, what is this, 10x minus 0.01x squared, okay, minus 0.1x minus 25. We take this and we simplify this, and we get, what is this, negative 0.01x squared minus 9.9x minus 25. This is our profit function. Now, all we need to do is use our technology to maximize that function, to find the vertex, and we'll find that the maximum level is x equals 495 cookies, okay? Okay, in this second problem, you're gonna do a graph of this, and what you're gonna end up with is this graph that looks kind of like this, okay? And when you find the minimum of this graph, and you can see that this is C of x and this is x, where x is the number of pins in hundreds, and the cost in hundreds to produce x thousand pins. So this is x thousand pins, and C of x is the cost in hundreds. Okay, so when you graph this, you get a minimum of 5,2. Well, what does that mean? It means you should produce 5,000 pens for $200, because 5 is in thousands and 2 is in hundreds. Sometimes in a real world situation, you want to use different scales for X and Y, and sometimes you scale them in thousands and one in hundreds, and you got to understand how to interpret that once you find a max or a min or an intersection point or whatever. What's the largest rectangular area one can enclose with 14 inches of string? Pause the video and solve it. So here's a solution. 2x plus 2y equals 14, therefore y equals 7 minus x. So x times 7 minus x is the area that you are trying to maximize, okay? So this area right here will be the area you would maximize. If you plug that into the calculator and find the max, you'll solve the problem. I think it's like 12.25 inches squared, 12.25 inches squared, something like that, or 12.3 inches squared. Give it a try. If you have any questions, bring them to class. Thanks.